It's Wednesday, the 13th of March, 2024. These are the science and space headlines we're following on Talkin' Science. Go for launch. Gilmour Space gets regulatory approval. SKA-Low's first antenna installed. What's next? And Europa may not be as habitable as long thought. Welcome to Talkin' Science. NASA Administrator Bill Nelson says the American Space Agency was caught in a congressional compromise for spending cuts in the 2025 financial year. At his annual State of NASA address, the Administrator says he'll fight for all of the $25.4 billion they've requested, despite losing almost 10% of the budget last financial year. On to our stories of the week. The Australian Space Agency has awarded Gilmour Space an orbital launch licence, the first in the country. For more, co-founder and head of launch operations James Gilmour is beaming in. James, welcome to Talkin' Science for the first time. It's been a 2-year journey to get to this point.
Yes, it has been a bit of a road to get here, but we have achieved the launch facility licence under the Space Launches and Returns Act, which is quite significant for the company, but also the Australian space industry in general. Really exciting.
Yeah, it absolutely is. We see investment in launch facilities across the country, Southern Launch, Equatorial Launch, and you guys as well. What makes Gilmour's so different?
Well, look, I mean, we are the first of its kind. We expect that some others, like Southern Launch, should be on the back end of their launch facility licence. It's a bit different for us because we own and operate the site that we intend to launch our own vehicle from, so a little bit different. The site itself, I believe, has some tremendous and unique advantages, given that we are quite close to the sea, given our remoteness but not being too remote, and our ability to tap into some significant support from the community in terms of resourcing and building out the site, which has been extremely favourable.
Well, what I've learned over the past couple of years of covering sovereign rocket launch capabilities is Australia's prime position to polar and equatorial orbit, plus our vast coastline makes downrange operations just that little bit easier, doesn't it?
Well, public safety is our top priority at Gilmour Space, and a lot went into deciding that Abbott Point was extremely suitable for orbital launch. It is with great pride and satisfaction to be able to inform you that we have secured that launch facility licence, and we've been working well with the other regulators, Maritime Safety Queensland, to cover the sea space, CASA for the airspace change proposal, and a lot of other stakeholders on the ground as well. So safety is a top priority, and it has gone a long way with our collaborative efforts to inform and consult and educate and excite the various stakeholders around us to see this, what will be an amazing achievement for our company, but also Australia in general, with the launch of Eris in the coming months.
Well, the licence from the Space Agency and approval from the Department of Climate Change, Energy, the Environment and Water were the final and regulatory hurdle. But you've also been working closely with the traditional owners of the land since the beginning.
Yeah, so I didn't want to be measured, by our words, but by our deeds. I believe we did secure the fastest cultural heritage management agreement with the Kaibara Munda Yalga, who represent the Juru people, but wanted a bit more than that. So we worked with the deadly Robbie Paul to design the mission patch of the site, and we've worked with another artist, Gary Pryor, to provide some more paintings, which we proudly display in our office space. And, as we continue to grow, we'll look at extending other opportunities to particularly the local Juru population to see, them achieve greatness as much as we're aiming for it. So watch this space.
Rocket tourism is the byproduct of what you're doing up there at Abbott Point. What's the feeling like on the ground as launch day draws near?
Mate, it's huge. When Adam and I came some 3 years ago and said we want to launch rockets in their backyard, I think with some of our other peers domestically and abroad, they would have been shooed out of the town. Not in my backyard, but they took it at face value and have supported us ever since. We do expect that not necessarily now, but in the future, there will be significant tourism influx from our activities. There are a number of extremely beautiful places to watch our rockets leave Earth. And I don't think there's any better place to be, watching rockets leave Earth because of the complexity associated with launching rockets, whether environmental or technical. There might be delays or scrubs, so people will have to stay in region. And, we're literally at the gateway of the Great Barrier Reef, so a really easy opportunity to go and explore what's around this beautiful township.
Cannot wait to get up to the Bowen Orbital Launch Complex in the weeks ahead. I'm assured that a media day is coming. Looking forward to checking that all out. James Gilmour, Gilmour Space's co-founder and head of launch operations. Now, since I spoke to him earlier in the week, Gilmour Space has also announced a partnership with Frond Space Systems in New Zealand, who'll provide a drag sail system for Gilmour Space's MMS-1 satellite mission. The micro drag sail is a lightweight and compact device that can be deployed at the satellite's end of life to increase its drag and accelerate its deorbiting, aiding in meeting regulatory requirements, enhancing space sustainability, and reducing the risk of space debris. One of Earth's biggest science facilities, destined to provide an unparalleled view of the universe, is a step closer to reality, with the first of more than 130,000 2-metre-tall Christmas tree-shaped antennas being installed last week in Western Australia. They'll make up the SKA-Low radio telescope, and the first 10 field technicians have begun their work of installing the massive array, which, when complete, will see the SKA-Low telescope enable scientists to explore the first billion years after the so-called dark ages of the universe, when the first stars and galaxies were formed. Western Australia's array is one of 2 telescopes, with the SKA Mid in South Africa also under construction to form the giant radio telescope. Well, Australian-made flexible solar cells will orbit the Earth in a test to evaluate them as a reliable energy source for future space endeavours. Dr. Anthony Chessman is the CSIRO's Renewable Energy Systems Group Leader. Dr. Chessman, welcome to Talkin' Science. What's significant about these cells?
So the conventional solar cells that we've been launching into space to date have largely been rigid. So that means they're relatively heavy and they need components that can carry some weight to release them. So what we've been working with at the CSIRO are flexible solar panels that can be unrolled. So this means that they have lower weight because they're printed onto plastics, and because of the mechanism by which they can be deployed, that mechanism weight's been lowered as well. So lower launch weight is highly preferable for space applications where it's quite expensive to launch materials into space.
Well, they're on board Australia's largest private satellite, Optimus 1, love the name, which flew on board SpaceX's Transporter 10 mission last week, the culmination of a lot of crew hours to get this technology from the R&D phase. What are the mission goals to get this certified?
Well, to the best of our knowledge, this is the first time that modules of this size of this solar cell material have actually been launched into space. So just to get any idea of how it will actually perform in space will be fantastic. So we've performed terrestrial testing using simulated space conditions, changing the temperature, so those rapid temperature fluctuations that you find in space, also exposing to radiation that you'd expect in space. But really, you don't understand the performance of these materials until they're tested in space. So to get an understanding of their lifetime and efficiency in space, specifically in the low Earth orbit that Optimus 1 is in, will be fantastic.
Now, I've got a solar panel charging my second battery in the car, and I've dived into saving some money on my power bills as well. What's the difference between Earth and space applications of solar panels, solar cells?
Typically in space, we'll be using different materials. So on Earth, silicon solar cells they dominate the market, and for good reason. With the economy of scale for their production, they're quite cheap now, and they've demonstrated long lifetimes. So for on your rooftop or utility scale solar, they're absolutely fantastic. In space, you're typically looking for some different requirements. So you will want that really, really high efficiency because the space is relatively limited during launch. You need to push those efficiencies even higher, and then also look at how you can have those different deployment mechanisms so you can utilize the storage space during launch effectively. So today we do have silicon in space, but we also have another technology called triple junction solar cells and also gallium arsenide solar cells, highly efficient solar cells, but incredibly expensive to make. So the numbers that we sometimes see from industry partners is up to $1,000 a watt to get into space. So this is extremely expensive. We're looking at a technology that's cheaper to launch and also cheaper to manufacture. So because of that, we're using a different class of photoabsorber. So that's the material that absorbs sunlight to convert it into electricity. And we're working with a relatively new class of material known as perovskite. It's a very efficient photoabsorber. We can get almost complete light absorption with only 1 micron thickness layer. So that is 1,000th of a millimeter. You only need to have a layer that thin. It will absorb all the sunlight to convert into electricity.
Well, if successful, what could these cells mean for Australian manufacturing?
So what we'd love to see is that we can actually make these solar cells in Australia. So this has been another challenge for the Australian solar industry. The cost of making silicon wafers is really expensive, so we've been solely reliant on offshore partners to provide wafers and also largely modules as well to be delivered into Australia. The other problem as well is specifically when we're looking at the space-rated solar cells, like the triple junction that I mentioned earlier, the lead time is really long. You're typically waiting 18 to 24 months to get the solar cells. So what we'd like to be able to do is print these solar cells in Australia and deploy to Australian manufacturers of larger solar cell equipment or satellite manufacturers, and also to the international market as well. So one of the other benefits of using a printing-based technology is the capital requirement. So that's a requirement to establish a manufacturing facility is a lot lower than those other existing technologies.
CSIRO's Renewable Energy Systems Group Leader, Dr. Anthony Chessman. Australia's National Science Agency is exploring the potential of printed flexible solar cells as a reliable energy source for future space endeavours in collaboration with Australian space transportation provider Space Machines Company. Well, Jupiter's moon Europa, long thought to be a destination for humans in the outer solar system, might not actually be as habitable as first thought. Researchers in the United States and Europe have found the icy moon produces less oxygen than original estimates. In the past, astronomers thought that the liquid ocean of the moon could produce oxygen and hydrogen via a process triggered by radiation breaking up the icy surface. But the researchers of this new study say that there might only be around 12 kilograms of oxygen being produced per second at the surface, a far cry from the 1,100 kilos that was once thought. This new detail comes from the Juno flyby data from September 2022, recently analysed using the Jovian auroral distribution experiment located on Juno. The authors extracted the abundance of various pickup ions, which are charged particles generated by the breakup of atmospheric neutrals when they collide with energetic radiation or other particles. The 12 kilos of oxygen per second is at the lower end of the expectations inferred from previous models. Research from the University of Sydney and Sorbonne University suggests that giant whirlpools in warming oceans could run counter to ocean stagnation that some have predicted could impact the Gulf Stream. The team used the geological record of the deep sea to uncover a connection between the orbits of Earth and Mars, past global warming patterns, and the speeding up of deep ocean circulation. They discovered a surprising 2.4 million year cycle where deep currents wax and wane, which in turn is linked to periods of increased solar energy and a warmer climate. These cycles are called astronomical grand cycles, predicted to occur occur due to the interactions of Earth and Mars orbits. However, evidence for this is rarely detected in the geological record. The study has identified that deep eddies were an important component of earlier warming seas. It is possible these could partly mitigate ocean stagnation. Some have predicted could follow a faltering Atlantic meridional, overturning circulation that drives the Gulf Stream and maintains temperate climates in Europe. How the interplay between different processes driving deep ocean dynamics and ocean life may play out in the future is still not well known, but the authors hope that their new results will help with building better climate models. Fascinating stuff. Well, recent observations of Betelgeuse have caused a bit of a stir, and it all centres around its spin cycle. It's just blazing by so fast, faster than a star its size should be able to, at least to our understanding of astrophysics. But a team at the Max Planck Institute for Astrophysics may have the answer. It could be an illusion whipped up by the violently boiling surface. With a diameter greater than 1 billion kilometres and a brightness that dominates the Northern Hemisphere's night sky, Betelgeuse is over 1,000 times larger than our star and well placed for study. Recently, observations of its dimming brightness have proven that it can still throw surprises at us, and now ALMA's findings on a dipolar radial velocity map that it's rotating at around 5 kilometres per second hinge on interpreting Betelgeuse as a sphere, ignoring the boiling bubbles cratering its surface. Upon investigation, 3D radiation hydrodynamic simulations show a cluster of boiling bubbles rising in one hemisphere and falling in another. This convection is blurred in actual observations, making it indistinguishable from rapid rotation. Further observations are needed to put theory into practice. Roscosmos and the China National Space Administration have announced their intention to build an automated nuclear reactor to power a joint lunar outpost by 2035. Director General of Russia's space agency, Yuri Borisov, told Russian state media that the project would be undertaken without the presence of humans and that the necessary technology to make it happen is almost ready. Nuclear-powered rockets are also set to be used to transfer cargo to the lunar outpost, but the necessary construction methods for those are yet to be finalised. NASA is considering a similar power station, with British scientists last year unveiling plans for a compact nuclear reactor powered by seed-sized fuel cells. Watch this space as a new space race heats up. I'm looking forward to it. Well, Trekzone membership gets you in first releases and first details. With a few tiers and a few options, you can help Australia's only science, space and science fiction podcast pick up the pace in 2024. Hey, we're in the third month already. I've got to change that script. Facebook, Instagram, TikTok and YouTube Shorts all have podcast highlights, so find us where you are. For now, this is Talking Science for the 13th of March, 2024.